trigonometrical functions. We have done some basic on integration of trigonometrical functions. But now let's talk about powers of trigonometrical functions. Now, what do we mean by this? So we are talking about powers of trigonometrical functions. You know, we are talking about sine x dx. Because you know when we integrate this, it's going to give us minus cos x. This one, we have cos x dx. That's going to give us sine x. Because if you integrate this, if you differentiate this, it's going to give you this. Now, we come across situations like sine square x dx, cos cube x dx, etc. You see, to integrate this, it makes it, there is like serious difficulty in just integrating this dx. It's not that easy. So we just look at, okay, what do we do? Just like we have done in that of parts and whatever, integration by parts or partial fraction. So we now look at it like, okay, we make it into, instead of trying to integrate it like this, we convert this one to multiples of sine instead of the powers of sine. Now, what do I mean? Look at this. Cos 2x is equal to cos square x minus sine square x. Do you understand? So, if I want to get sine 2x, sine square x, so I can now say cos 2x is equal to 1 minus sine square x minus sine square x equal to 1 minus sine square x. So, sine square x is equal to 1 minus cos 2x over 2. So you can see. So this one can be easily integrated with respect to x, and this one too can be easily integrated. Now let's look at that of from this place. You can also do that of the cos. So you have cos 2x is equal to cos square x minus 1 minus cos square x is equal to 2 cos square x minus 1. So what does that mean? 2 cos square x is equal to cos 2x plus 1. So I can now say that cos square x is equal to 1 plus cos 2x over 2. So if I want to integrate this one now, you see it is not easy. Very easy. Let's see what it should be like. Now we have established that sine square x is equal to 1 minus cos 2x over 2. And cos square x is equal to 1 plus cos 2x over 2. Now, if I want to integrate now, I have got two better expression to replace it. So sine square x is equal to dx is equal to 1 minus cos 2x over 2 dx. So you can see, it's going to give me half 1 minus cos 2x dx. So this is going to give me half into x minus sine 2x over 2 plus, which is x over 2 minus sine 2x over 4. So you can see, it has made our job very easy. So this is the basic thing you need to know. You should be able to know that you express this in terms of cos 2x. You express that in terms of cos 2x. Let's quickly do that of cos square x. Now, let's do at cos square x dx. It's the same thing as half 1 plus cos 2x dx. So this one is going to give me half into x. If we integrate this one, it's going to give us minus sine 2x over 2. makes our work very easy. Now we have done that of sine square, cos square. We are now looking at where we are having it like sine cube, cos raised to power 4, sine raised to power 5, etc. Let's see how we handle those ones. Now let's look at when the powers are even. That is, powers are even numbers. What I mean is this: when you are having it like sine square x, sine raised to power 4, cos raised to power 4, or cos square x, cos raised to power 4x, etc. You understand what I mean? We have done that of when it is sine square, when it is cos square. But when it is even, when the powers are even and odd, they have different ways of handling them. When it is even, you have to break it down into multiples of the angles. Multiples of the angle. But when it is that of the odd, it will still be in powers. It will still be in powers, but there is a way of handling that. When we get there, we will handle it. Now let's start with sine raised to power 4. We have done that of sine square and cos square. So sine raised to power 4x dx. You see? It will be sine square x square dx. You can see. So, because this one is not a differential of this, we cannot easily manipulate it. So we have to handle this one and break it down into multiples of the angles. So we make it the multiples of this angle. So what do? We have seen that sine square x is equal to 1 minus cos 2x half. So we will substitute this with this and then square it. Let's see how it goes. So is equal to 1 minus cos 2x all square raised to dx. Then let's expand this. You are going to have 1 over 4 to 1 minus 2 cos 2x plus cos square 2x dx. You can see we are still meeting the same big word here again. So you have to expand this again. So cos square 2x will equal to half 1 minus cos 4x. So you see, so I will substitute this back here now. So this will be equal to 1 over 4, 1 minus 2 cos 2x plus half 1. Oh, sorry, this one is half 1 plus cos 2x cos 4x dx. Please take notes. Cos square 2x is 1 plus cos 4x half. So this will be equal to 1 over 4, 1 plus half minus 2 cos 2x plus cos 4x dx. So we should be equal to 1 over 4 into 3 over 2x minus 2 sine 2x over 2 plus sine 4x over 4 plus c. So our final answer is going to be 3 over 8x plus sine 2x over 4 plus, this one is supposed to be over 2. So this one will be over 8 plus sine 4x over 32 plus c. So please take notes of this. Now let's work on this. Cos raised to power 4x dx. As you know that will be cos square x all square dx. And we know that cos square x is equal to 1 plus cos 2x over 2. And that's going to be 1 plus cos 2x over 2 squared dx. Now let's expand this. 4, 1 plus half plus 2 cos 2x plus cos 4x over 2 dx. So let's 3 over 2 plus 2 cos 2x plus cos 4x over 2 dx. Now let's do the integration proper now. So it's going to give me 3 over 2x plus 2 sine 2x over 2 plus sine 4x over 4 times 2 plus c. So what is that going to give us? It's going to give us 3 over 8x plus sine 2x over 4 plus sine 4x over 32 plus. Now, so assuming we have it like cos raised to the power 6x, sine raised to the power 8x, you follow the same pattern. But if you are used to complex numbers, there is a way you can find all these things easily using de Moivre's theorem. So, or you do this expansion like this, you get your answer. That's how it is. Now, let's look at it when the powers are odd. What do we mean? Like when we have it like sine cube x, cos raised to the power 5x, sine raised to the power 7x, cos raised to the power 9x, etc. That is, the powers are odd. So, let's look at this. We are going to check that of sine cube x dx. The way we handle this, we don't make it to that of multiple of the angles. It will still be in powers, but there is a technique we are going to use. Look at it very well. It's going to be, we will always separate one of these you see, because it is even. This one is sorry, you see, because this is odd, I remove even parts and remain one part to serve as my let me see, derivative behind. So this one will now look like z square dz. At the end of the day, we have not gotten there yet, but at the end of the day, this is what it's going to be like. Now, let's continue. So I just prepare your mind. We have established that this one is sine square x, so you see, at the end of the day, this one is going to be 1 minus cos square x sine x dx. Now see how funny it is now. Very interesting. So we are going to have sine x minus cos square x dot. Let me put it like this. So we are going to have sine x dx minus cos square x dot sine x dx. You see, it makes the job very easy and straightforward. So you can see that we have come to that kind of expression I was showing you the other time. This one, we can easily integrate this. So when you integrate sine x, it's going to give you minus cos x. You can see this one now is like a derivative of cos x minus cos x. You understand now? So you can say minus cos square x minus dot minus sine x dx. So you can see what I did. Because if you differentiate cos x, it's going to give you minus sine x. So this one is just going to be like z squared minus cos x plus cos cube x over 3 plus c. So you see what's happening now? This one is even easier than that of the odd. Straight. So if it is raised to power 5 down, just bring it sine raised to power 4, sine raised to power dot sine x dx. So it's very easy. Now we have cos raised to power 5x dx. You can see the power is odd. The power is odd. So I can now put it like this. Cos raised to power 4x dot cos x dx. You know, because why do we do it? If this one is cos, at the end of expansion, you are going to have every expression in terms of sine. If it is sine that is here, by the time I expand it rather, it's going to give me everything in sine. So I'll be able to do like that z or whatever. So let's continue. So this one is going to give us cos square x square dot cos x dx. Now let me work on this. You know that cos square x is equal to 1 minus sine square x. So cos raised to power 4x will be equal to 1 minus sine square x all square. And that's going to give me 1 plus sine raised to power 4x minus 2 sine square x. So I'm going to put this one in this place. So it's going to give me 1 plus sine raised to power 4x minus 2 sine square x cos x dx. So let me now work it out. So for ease, why don't I do it like this? Cos x plus sine raised to power 4x dot cos x minus 2 sine square x cos x dx. So you see, it's very easy now. If I should differentiate sine x, it's going to give me cos x. So I have sine x here. Sine raised to power x, this one is going to be raised to power 4. If I should differentiate, integrate this one, I'm going to have this. So plus sine raised to power 5 x over 5 minus 2 sine cube x over 3. So please, whenever you are doing it, always try to consider if you will need to put minus here and change the sign here so that your work will be very easy. Assuming we have it like cos raised to power 4x dot sine x. If it is plus here, put minus here so that your work will be very easy. I'll explain that later. What I was saying is this. If you have it to be like this, cos raised to power x dot sine x dx. You know that if you differentiate cos, it's going to give you minus sine x dx. So for that one to work out well for you, put minus here and put minus here. So it still retains the positive. But you know that when you differentiate cos x, d dx cos x is equal to minus sine x. So it makes your job easier by already putting minus here, and there won't be confusion at the end of the day. So minus here. So please take notes. Now let's look at products of sine and cosine. Let's look at products of sine and cosine. Now we are talking about products of sines and cosines. Like when we have it in multiple angles. Like if we have it like this, sine 3x cos 4x dx. And I will try to quickly, remind us about how to handle this product. You know that sine a plus b is equal to sine a cos b plus cos a sine b. Please remember this. that sine A minus B will be equal to sine A cos B minus cos A sine B. Same thing for cos. Cos A cos B minus cos A minus B. Cos A cos B plus sine A sine B. Now let us add this. Let's add this to. Let's see what it gives us. We know that we have sine A plus B minus sine A minus B. Oh, plus. What does that give us? It's going to give us 2 sine A plus B. Please take note. If we subtract it, sine A plus B minus sine A minus B. What does it give us? 2 cos A sine B. You can see cos A plus B plus cos A minus B. If you add this, it's going to give us 2 cos A cos B cos A plus B minus cos A minus B. What is that going to give us? You see, minus 2 sine A sine B. So, what does this imply? When you have it, we can even work it direct. Maybe I do that. But if you can get it to this point, you can easily work this out. I have sine 3x cos 4x. Come to this place. You see. So, which means that I just put like this 2 sine 3x cos 4x is going to give me sine 3x plus 4x plus sine 3x minus 4x. You can see 2 is here. Please don't forget. So at the end of the day, this one is going to give me, so it's going to give me sine 7x, okay, sine 7x plus sine minus x. So I put half here. It's equal to sine 3x cos 4x. So if you can do your expansion and get to this, you can easily work it back straight. You can easily work it back. And that's just it. There's no need of special working forward again. You can bring this one here and it will give you this answer. Now, let's do like some examples. So, for this sine, to have sine, mixture of sine and cosine, you know that we work with the sum of these two sides. For cos, we have these two. So, let's work out. Now, let's do this one. The first one is sine 4x cos 2x dx. And that will give us sine 4x plus 2x plus sine 4x minus 2x dx. Please don't forget to put the half at the front here. Don't forget. So, we are going to have half sine 6x plus sine 2x. Yes. So that's going to be half. It's going to give me half into minus cos 6x over 6 minus cos 2x over 2 plus 2. And that's going to be minus cos 6x over 12 can see this one is very easy and straightforward. Straight. Now, this one is going to be sine 5x plus 3x minus sine 5x minus 3x dx. Please don't forget this half. I said it. Don't forget this half. When cos is before, this sign here will be minus. If sine is the one ahead, they are positive here. So we are going to have half sine 8x minus sine 2x dx, which is half into minus cos 8x over 8 plus cos 2x over 2. So it's going to give me cos 2x over 4 minus cos 8x over 16. Now let's look at the third one. We have cos 6x cos 4x dx. So you can say it's equal to cos 6x plus 4x plus cos 6x minus 4x dx. So it's going to give us half cos 10x plus cos 2x dx. So it's going to give us half into sine 10x over 10 plus sine 2x over 2 dx. And that's going to be sine 10x over 20 plus sine 2x over 4 plus 2. Now we have this sine 5x sine x dx. We are going to have it like this. This will be cos 5x minus x minus cos 5x plus x. Please don't forget this. So it's going to be half cos 4x minus cos 6x dx. What do you have now? Half. This is going to be, when we integrate this one, it's going to be sine. So we are going to have sine 4x over 4 minus sine 6x over 6. Sine 4x over 8 minus sine 6x over 12. So you can see, we just brought the knowledge of difference of the sum, addition of the sum of angles, and all the sine of angles, cosine of angles to solve this. So you can see how easy it is.